Welcome to this video. Now we see in this video Thevenin's theorem. This is one of the most important theorem in the network analysis. What is the statement of this network theorem? Statement said it states that any complex network can be replaced by a series consisting of an ideal voltage source that is called VTH and a resistance RTH. Meaning is that in वी हैव सपोज एनी कॉम्प्लेक्स नेटवर्क, अगर हमारे पास किसी भी तरह का कॉम्प्लेक्स नेटवर्क है, सपोज दिस इज वन ऑफ द कॉम्प्लेक्स नेटवर्क, दिस कॉम्प्लेक्स नेटवर्क इट इज पॉसिबल टू रिप्लेस्ड बाय द सिंपल सर्किट. किसी भी कॉम्प्लेक्स नेटवर्क को हम एक सिंपल सर्किट में कन्वर्ट कर सकते हैं और वो सिंपल सर्किट में कन्वर्ट करके वोल्टेज सोर्स इन सीरीज विद द रेजिस्टेंस इस तरह से उसको हम कन्वर्ट कर सकते हैं अगर वो हमारी कॉम्प्लेक्स सर्किट है तो. सो दिस इज द थेवेनिन थ्योरम. इट स्टेट्स दैट एनी कॉम्प्लेक्स नेटवर्क कैन बी रिप्लेस्ड बाय ए सीरीज consisting of an ideal voltage source and a resistance is in series. It is possible to show. So this VTH, because this theorem given by the Thevenin, we called Thevenin voltage VTH, resistance that is the Thevenin resistance RTH, it is possible to show in series, and the load resistance would be to the point A and B. So it is possible to show. Suppose we have one circuit. This is a one complex network. We are still looking in this one. See, this is the voltage source V, resistance R1, resistance R2, resistance R3, and to the point A and B, in between that we connected one of the resistor that is called the load resistance RL. So we considered this is the complex circuit, and this complex circuit can be replaced by voltage source in series with the resistance RTH. So इस कॉम्प्लेक्स सर्किट को हमने सिंप्लीफाइड फॉर्मेट में कन्वर्ट करके वोल्टेज सोर्स है VTH that is a Thevenin voltage, RTH that is a Thevenin resistance, and the load resistance we connected to here. So this is the simplified diagram of this complex network. It is possible to convert, and how much current are passing from the load resistance RL, it is possible to find out. That is IL is equal to that formula, I equal to V by R. So I is equal to VTH upon RTH plus RL, this RTH plus RL. So IL is equal to, that is the load current passing from this load resistor, is equal to IL equal to VTH upon RTH plus RL. It is possible to verify and prove. ये हम कर सकते हैं. तो थेवेनिन का इतना ही कहना है कि किसी भी तरह की कॉम्प्लिकेटेड सर्किट अगर है तो उस कॉम्प्लिकेटेड सर्किट को हम सिंप्लीफाइड फॉर्मेट में करके वोल्टेज सोर्स इन सीरीज विद द रेजिस्टेंस इस तरह से कन्वर्ट करके हम लोड करंट उसमें से कितना पास हो रहा है वो हम फाइंड आउट कर सकते हैं. टेक वन एग्जांपल. इन दिस take one example. See how we find out the VTH and how we find out the RTH. In this diagram you see this is the complicated circuit. We simplified to the simple circuit, then we find out the IL is equal to VTH upon RTH plus RL. But how to find out the value of VTH? How to find out the value of RTH? So for that there is some steps. That steps we have to see. So first step, that is to find out the value of RTH. सबसे पहले हम देखते हैं कि VTH की वैल्यू कैसे फाइंड आउट करते हैं और RTH की वैल्यू कैसे फाइंड आउट करते हैं वो उसको हम देखते हैं. So first see, finding VTH. What we have to find out in this equation, you see IL is equal to VTH upon RTH plus RL. But how to find out the value of VTH? So for that there is some steps. For that there is some steps. And what are that steps? What are that steps? You see, in this one, we removed the load resistance RL connected to the point A and B. यहाँ पे जो लोड रेजिस्टेंस RL था उसको हमने निकाल दिया. Now see, this is the voltage source V. R1 is connected, R2 is connected, and R3 is connected. You see here, one of the end of the R3 is connected to this point, but another end of the R3 is not connected to anywhere. मतलब दूसरा टर्मिनल जो है ये इधर कहीं पर भी कनेक्ट नहीं है. मतलब R3 के कारण कोई सर्किट इसकी कंप्लीट नहीं हो रही है. दिस इज इंडिपेंडेंट. ओके, सो एक्चुअली सर्किट इज लुकिंग लाइक दिस. इस तरह से सर्किट हमारी बन रही है. दैट इज R1, this is R2, and here the applied voltage, here the applied voltage V. This V, this is R1, and this is R2. Because R3 is independent, one of the terminal is connected to here, but another terminal is not connected to anywhere. Okay, now we have to find out the current, how much current are passing from this रजिस्टर R2. इस R2 में से कितना करंट पास हो रहा है वो अगर हमें पता करना है, दैट इज द करंट थ्रू R2 इज इक्वल टू, दैट इज I इज इक्वल टू V बाय R. I इज इक्वल टू दिस, ये फार्मूला I इज इक्वल टू V बाय R. So V, that you know, this V, R is what? That is R1 plus R2, because the two resistors are connected in series. So I equal to this, I equal to V upon R1 plus R2, that is R is equal to R1 plus R2. इस तरह से हम ये इक्वेशन बना सकते हैं. Because R3 is connected one of the end, but another end is not connected. That's why how much current are passing from the R2, it is possible to find out. That is I is equal to V by R. So V is simply applied voltage, this. R is simply, that is R1 plus R2. So this is the current, how much current are passing from the resistance resistor R2. This we find out. Now we have to find out VTH. So that is our aim, to find out the VTH. That is our aim, to find out the VTH. How we find out the VTH? Now you know again, the V is equal to I into R. V is equal to I into R. So the value of I, we find out, this is the value of I, that is V upon R1 plus R2, then into R. किसके across में? Across this. We are finding across this. We are finding across this. This is the actual VTH we are finding across this. So V is equal to I into R. This is I into R2. So value of I that we know, that is V upon R1 plus R2 multiply by R2. Then we find the value of VTH. This is the VTH we find out in this equation. अब इस इक्वेशन का मुझे VTH जो है वो मिल गया. इस इक्वेशन का VTH हमको मिल गया. नाउ वी हैव टू फाइंड आउट द RTH एंड RL. RL की वैल्यू तो पता है हमको. वी हैव टू फाइंड आउट द VTH. सी how we find out the VTH. Now our aim is to find out the RTH, that is the resistance. So short this terminal. इस टर्मिनल को हमने शॉर्ट कर दिया. Why? Because we want to find out the simply only resistor. Now after shorting this two terminal, there is a resistance R1, resistance R2 and the R3. We have to find out the total resistance of the सर्किट. इस सर्किट का टोटल रेजिस्टेंस कितना है वो पता करना. नाउ दिस R1 and R2 इज इन पैरेलल. इस तरह से वो पैरेलल है. दिस इज R1, दिस इज R2, दिस इज R1, दिस इज R2 and the R3 are connected here. So R1, R2 is in parallel and this R3 is in series. So R1, R2 parallel है. So R1 multiplied by R2, R1 plus R2 plus R3, because this R3 is in series. So if we calculate that one, we will find out the value of RTH. So in this way, it is possible to find out the value of VTH, RTH, and we know the value of RL. Put all these values, then find out the load current IL that are flowing from the load resistance RL. So this is the way to find out the value of load current passing from the any circuit. So that is our aim, how to find out the value of IL. ठीक है, इस तरह से हम उसकी वैल्यू पता कर सकते हैं. नाउ टेक वन एग्जांपल by using the Thevenin theorem, how to find out the value of IL, that is the load current passing from the load resistor RL. Now this is one of the circuit. In this circuit you see this is the applied voltage V, that is a 36 volt. R1 is given 3 ohm, R2 is given 6 ohm, R3 is given, that is a 4 ohm, and the load resistor is given, that is a 12 ohm. So again our formula is very simple, that is a IL is equal to what we have to find out, that is a VTH upon RTH plus RL. So this is our formula using the Thevenin theorem. First we have to find out the VTH, then we have to find out the RTH, then RL value that we know. Just put the value of VTH and RTH to this equation and find the value of load current IL, that is flowing from the load resistance RL. So see how we find out the value of VTH first. Now see, to find the value of VTH, remove this load resistor RL. After removing this load resistor RL, you see this 4 ohm resistor, one of the terminal is not connected to anywhere. So we have to find out the voltage across this C and D. Now see, again, what is our formula? That is VTH is equal to, that is V is equal to simply I, that is I are passing from the resistor R. I, that is passing from the resistor R. So we know the value of resistor R, that is a 6, but we don't know the value of current I. So formula is I is equal to V upon, that is a R1 plus R2 that we had seen, R1 plus R2. Now we know the value of V, that is a 36. So we will put the value of 36. Then R1, this is the R1 and this is the R2. So R1 is a 3, this is a 3 ohm and this is a 6 ohm. So we will put the value of 36. This is a 36 upon 3 plus 6. We will get the output, that is a 4 ampere. Means in this equation we find out the value of I. Then VTH is equal to I into R, that is across the 6 ohm resistor. I are passing from the 6 ohm resistor. So this 4 ampere, that is I, multiplied by 6 is equal to 24 volt. So voltage across C and D, that is a 24 volt that we find out. So in this one, we find out the value of VTH. Now we have to find out the value of RTH. So how we find out the value of RTH, that we have to see. So in this one, to find the value of RTH, you see we just shorted the source terminal, and after shorting the source terminal, this is one of the resistor, this is another resistor, and this is another resistor, and all that is a this is a 4, this is the 4. So This 3 ohm and 6 ohm is in parallel like this. This is a parallel, and this 4 ohm is in series. This 4 ohm is in series. This is a 3, this is a 6, and this is a 4. So how much? As per formula, 3 into 6, 3 into 6, both are parallel, upon 3 plus 6 plus in series 4, you will get the value of RTH. So as per the formula, load current IL is equal to VTH upon RTH plus RL. So value of VTH is at 24, we find out. Value of RTH we find out, that is a 6. Okay, so you will get the value of RTH. Then put the value of load resistance RL, that is at 12 ohm. So after putting this, you will get the value 1.33 ampere in between the point A and B. That is, a current IL are passing from the load resistor RL, that is a 1.33. It is possible to find out by using the Thevenin theorem. So simply in the Thevenin theorem, what we have to do, you have to find out the value of VTH first. You have to find out the value of RTH. Then after finding the value of VTH and RTH, put in the equation, that is IL is equal to VTH upon RTH plus RL. Then find out the value of load current RL. So this is the way, by that way it is possible to find out the value of load current. So this is one of the question, that is in this one, you see the voltage source is given. This voltage source is given 25 volt. R1 is given, R2 is given. Another resistor we connected here, that is R3, and this R4 is also connected here. Again here, what you have to find out? You have to find out the VTH. You have to find out the RTH. Then after finding the VTH and RTH, it is possible to find out the load current RL. Only thing is that one of the resistor we connected, because one of the resistor is connected, so when we find out the load resistance RTH, that time this one be in series with the R1. R1 के सीरीज में होगा और ये जो है पैरेलल में होगा. R1 प्लस R3 ये सीरीज में होगा और R1 R3 इसके पैरेलल में होगा. ये जब आप RTH पता करोगे तो. So this is the way to find out the value of load current IL. So I hope you will solve this equation circuit.